In number 10, we're asked to add these two fractions together, and what you'll notice about their denominators, y minus 3 and 3 minus y, is that they're opposites. That makes it fairly easy to find a common denominator. Let's just multiply the second fraction by -1 over -1. So this is y divided by y minus 3 plus, and now we multiply that -1 to each term in the numerator and also to each term in the denominator. So that's going to give us -y plus 7 over y minus 3, because -1 times 3 minus y is its opposite, y minus 3. Now I'm going to add the numerators together and simplify the numerator, and the final answer is 7 divided by y minus 3. In 11, we're asked to add two fractions again. What I'm going to do is factor the denominators. The first denominator factors into x plus 5 times x minus 5. And then the second fraction, the denominator does not factor. What we'll need to do is multiply that second fraction by x minus 5 times x minus 5. Remember those understood parentheses when we multiply. So the first fraction is 20x divided by x plus 5 times x minus 5, and the second fraction is going to have that same denominator, x plus 5 times x minus 5, and before we add numerators, which is what we do when we have fractions with a common denominator, then we'll need to multiply those factors in the numerator, because you have to multiply before you can add. So multiplying x minus 5 times x minus 5, you can use the FOIL method or a box, but the result is x squared minus 10x plus 25. Now we're going to add the numerators and keep that denominator, x plus 5 times x minus 5. Let's simplify the numerator, combining like terms. That's x squared plus 10x plus 25. And the numerator factors to x plus 5 times x plus 5. Now we can cancel common factors of x plus 5 in the numerator and denominator, and our final result is x plus 5 divided by x minus 5. In number 12, we're asked to subtract two fractions. First thing I'll do is factor that first denominator. It factors into x plus 2 times x plus 4. And the second fraction has a factor of x plus 4 in its denominator, so we'll need to multiply that fraction by x plus 2 times x plus 2. Remember those understood parentheses as we multiply. So first fraction is x squared divided by that least common denominator of x plus 2 times x plus 4. And then the second fraction will have that same denominator of x plus 2 times x plus 4. And in order to subtract the numerators, which is what we do when we subtract fractions with like denominators, we need to multiply first. Multiplying x minus 4 times x plus 2 gives us x squared minus 2x minus 8. Remember how we subtract fractions. What I want you to do is to change it to addition of the opposite and change every single term in the numerator of the second fraction to its opposite sign. So now we're going to add the numerators. So we have x squared plus negative x squared plus 2x plus 8, and then downstairs x plus 2 times x plus 4. And so adding or simplifying, we get 2x plus 8 divided by x plus 2 times x plus 4, and two factors from the numerator, and then common factors of x plus 4 can be canceled or divided out, and that leaves us with a final answer of 2 over x plus 2. In 13, we're asked to subtract two fractions with unlike denominators. So my first strategy here will be to factor each denominator. I'm going to leave a little bit of space in between to multiply each fraction by something. So we get 3 times t plus 2 and 4 times t plus 2. That means we can find a common denominator of 12 times t plus 2 by multiplying fraction number 1 by 4 over 4 and fraction number 2 by 3 over 3. Remember those understood parentheses around the numerators, which are binomials of each of those fractions. So each of our denominators will have that new least common denominator of 12 times t plus 2. And in order to subtract numerators, which is what we do when we have subtraction of two fractions with like denominators, we have to multiply first by order of operations. So the numerator of the first fraction is 4 times t minus 1, which is 4t minus 4. The numerator of the second is 3 times t minus 2, which is 3t minus 6. Remember how we subtract fractions. I want you to change it to adding of the opposite, and you must change both signs, the signs of both terms in the fraction that's being subtracted. So let's add the two numerators together, 4t minus 4 plus negative 3t plus 6, and then keep that denominator. And combining like terms, we have t plus 2 divided by 12 times t plus 2. Now we can cancel common factors, and when we have no common factors left in the numerator, or no factors at all in the numerator, remember that leaves us with a 1. So the fraction in reduced form is 1/12. In 14, we're dividing, so what we're going to do with that is turn it into a multiplication. And as I'm turning it into a multiplication, I'm also going to I'm going to factor each numerator and denominator so that we can cancel common factors. Since in multiplication, you can cancel common factors in numerators and denominators. So I'm going to flip that second fraction over as we change this to a multiplication problem, and a factor of n can be factored out, and that leaves us with 2 minus n. So n times 2 minus n over 1 is the reciprocal of that second fraction, but in factored form. Now I'm going to cancel some common factors. N minus 2 and 2 minus n are opposite factors, so when we divide them out, opposites divide to give you a result of negative 1. And now we can multiply all the factors that remain. Negative n times n is negative n squared, and then the denominator is n minus 3, and that's our final result for this one. In 15, we have a multiplication of two fractions, and when we multiply, we just multiply, but we want to cancel common factors first. So the numerator of the first fraction factors to a minus 3 times a minus 3, or a minus 3 squared if you want to write it that way. And then the denominator, we can factor out a common factor of 2a, and that leaves us with 2a times a plus 2. The numerator of the second fraction we can factor out a common factor of a squared, and that will leave us with an a squared minus 4. And then in the denominator we can factor out a common factor of 3. That'll leave us with an a minus 3. Let's cancel some common factors. A minus 3's cancel, and that's all we can cancel for now, maybe. Well, maybe we can cancel more, but I'm going to write this a little differently as we move to our next step. So the factors that remain are a minus 3 and the a squared in the numerator, which is really a times a, and then the factor of a squared minus 4 factors to a plus 2 times a minus 2. Downstairs, we have 2 times 3, which is 6, times a plus 2. Now let's grab our cancellation pen and cancel some other common factors. Factors of a plus 2 can cancel, and the factors of a can cancel. And that's going to leave us with a final result of a times a minus 3 times a minus 2 all over 6. All right, let's move on to the next section, which is complex fractions. And in a complex fraction, we can have a complex fraction that doesn't necessarily look like a complex fraction. So when we simplify it, we may want to change each of these negative exponents to an expression that is expressed with positive exponents, so it'll be in fraction form. So x to the negative 2 is 1 over x squared. And then x to the negative 1 is 1 over x. I'm going to simplify that a little bit. That's 1 over x squared over x plus 3 over x, because when we multiply two fractions together, we multiply their numerators, which are the 3 times 1, and their denominators 1 times x. Now I'm going to multiply the top and the bottom by the least common denominator of the little mini denominators, which is x squared. From this point, the numerators 1 over x squared times x squared yield a result of 1. In the denominator, remember, we have to distribute that x squared to both terms, so that's going to leave us with x cubed plus 3x. And that can be our final answer, or you can leave the answer in factored form, 1 over x times x plus 3. And what I meant by that was 1 over x times x squared plus 3. In number 17, all of our mini fractions are already in fraction form, so I'm going to multiply by the least common denominator of all 4 of these fractions, which is 4 times a squared over 4 times a squared. In other words, we're going to multiply the numerator of the big fraction times 4a squared and the denominator of the big fraction times 4a squared. Now remember that we have parentheses that are understood around each binomial in the numerator and the denominator. So now let's distribute 4a squared times 1/4 is 4a squared over 4. 4a squared times 1 over a squared is 4a squared over a squared. Downstairs, 4a squared times 1/2 is 4a squared over 2. And 4a squared times 1 over a is 4a squared over a. Now, if you can do this simplification in your head, you don't have to write that step, but you may want to write out this step and then simplify each fraction. So you'll notice that each fraction divides evenly, so that leaves us with a non-fraction result, a squared minus 4 in the numerator, and 2a squared plus 4a in the denominator. Okay, now let's factor each numerator and denominator so that we can cancel some common factors. 2a factors out of the denominator, and then that's going to make our a plus 2's divide out or cancel. And so that's going to leave us with a final result of a minus 2 divided by 2 times a. In 18, I'm going to multiply the big fraction times the least common denominator of the little fractions over itself. So n plus 1 times n minus 1 over n plus 1 times n minus 1. So let's multiply those out. So remember to distribute to each of the terms in the numerator. So distributing to the first term, we get a result of n plus 1 times n minus 1 over n plus 1, plus, and distributing to the second term, we just get 1 times n plus 1 times n minus 1. And then downstairs, distributing to the first term, we get 3 times n plus 1 times n minus 1 divided by n minus 1. And then distributing to the second term, we get 1 times n plus 1 times n minus 1. Do not be tempted to cancel here because your numerator and denominator are not in factored form. Let's simplify each of the expressions here. The first fraction in the numerator, we can cancel those n plus 1s, and that's just going to leave us with n minus 1. Now we're going to actually have to combine some like terms here, so let's multiply this out. N plus 1 times n minus 1 is n squared minus 1. Downstairs, in the first fraction, we can cancel common factors of we can cancel common factors of n minus 1. So that's going to leave us with 3 times n plus 1, which is 3n plus 3, plus, and then we have that same multiplication to do, n squared minus 1. All right, that leaves us with the numerator of n squared plus n minus 2, and a denominator of n squared plus 3n plus 2. And we can factor n plus 2 times n minus 1 and n plus 2 times n plus 1, and cancel those common factors or divide them out, and that's going to leave us with a final result of n minus 1 divided by n plus 1.